let's start again from part 2 of your list. Okay, so the JCF in fact allows a list to be associated with any data type, and of course we can use the so-called generic keyword E to actually denote an arbitrary type that you can actually use with a list. So don't worry about this yet. The most important thing is you get to know how to use the array list. I think I mentioned all this, right? Comparing array list with our normal array and see how's the differences and so on. So this part I think is more or less clear, right? Take note that the array list in fact is actually inheriting from the interface called collection. And then there's another interface called list that is actually inheriting from collection. And then array list is actually inheriting from list. So you can see that the hierarchy of inheritance here. And then again, you notice that the top two are interface, right? And array list is an implementation, right? And that's to say that in array list, of course, it comes with a number of methods and also attributes that are associated with your array list. Okay, so it's somehow different from the interface. If you use the interface format, then you will have to implement a lot of those features mentioned in the interface. Okay, so don't worry. And when we use java.util.ArrayList, you are actually using an implementation of list. Okay, and as I mentioned to you, you can actually declare the list like this using ArrayList angle bracket string, or without this one also is fine. Okay, and to add the element, I think I've already mentioned how to add the elements and so on. So there are many ways we can actually initialize our array list. One way is by initializing it with no size detail. If you don't specify the size in the round bracket, then it will be just an empty array list, okay? And you will determine the list length after you have added the elements. But if you want to fix the size, what you can do is this will be an array list of type string. You don't have to put the string keyword here, and then you just put the size 10 after the array list definition, okay? Then it will allow you to actually have an array list of size 10. And the rest of the methods, I think I've actually demonstrated to you. If you want to clear all elements, there are two ways. One is to use the remove all. The other one is to use the keyword clear, right? There are two ways you can clear the elements inside your array list, okay? And for list, right? All the methods that you use here, they're actually quite standard. And because those are inherited from interface, so the usage becomes easy because now you don't actually have to worry about what's the so-called method to be called, right? So the remove can be on a precise match using an object or a precise index, okay, that you can use to refer to that particular element. And then we have the clear and so on. So this one, I think I'll go through very quickly because we have already covered this part, right? And to get the element, I can just use the list dot, okay, my list dot get index number 0. That means I'm getting the first element. So then you'll be able to actually read the first element that you have added. That's the keyword some string, right? Okay, so apart from that, to search through your array list, you can use the contains to return whether some element actually exists in your array list or not. So it will return true, false in that case. So all these methods are quite standard, all right? And then we have also used index of. Unfortunately, I didn't actually show to you. When you use index of, you will be able to know the very first occurrence of a particular element, right? And last index of will be the last one. If there's no match, it will return -1, right? So, and if your array list is empty, you can just use the method dot is empty to determine whether your list is empty or not. And then the size will return the number of elements inside your list, okay? And then we can also use an object array method, right? So in this case, the method called toArray actually converts your whatever type that you have inside your array list into an object array, okay? So the object array needs to be cast to the right type in order to be valid, right? Like for example, if you have a string array inside your toArray method, when you convert the content into a string array, then you have to actually cast the return type into a string array. Okay, so anyway, these are just the methods that you can actually use. And I think we are a bit disorganized today, so sorry about it, because too many disruptions, right? So I don't like to have class like this when I'm going in and then I have to basically get worried about too many things, right? So this is a comparison between array and ArrayList. You notice that array, of course, you can use only index in a square bracket, right? A square bracket. And then to find the size, you need array.length to know the length of your array. Okay. And then for array, when you actually initialize the array of certain size, you cannot change the size. All right. But whereas for ArrayList, it can grow. And there's no limit onto the size of that ArrayList. So in one sense, ArrayList is very flexible in the usage. If you have more than the number of elements, you can still increase, right? So what I'll do is I'll show you one example. Okay, over here. Let's start with a simple example here. And then we will be using our Java folder. And this will be examples, okay? So I'll just call it as examples whatsoever. So doesn't matter about typo. So what I want to do is I want to actually demonstrate using this at the Java here, right? So firstly, let's import java.util.ArrayList, okay? And sorry about this, I typed wrongly. Okay, it's an old habit. Okay, so then we can just say ArrayList string, for example, and then namelist. Okay, I call this as namelist. Is a new instance of ArrayList of size, let's say 2. Okay, and what happens if, let's say, I enter the element one by one? Okay, I add, let's say, Steve. I add again. Yo. Okay, and I add again. It's here, right? Right, so will it allow me to add all the elements? What do you think? So unlike array, of course, array will basically reject if, let's say, your initial capacity was defined and then your array list will not allow you to run. Okay, so for this one, definitely you run, no issues. Okay, and if you want to know the size, of course, you just say system.out.println, and I can just print namelist.length, okay, or the size in this case. The size is the right one, and then it will show you that we have an element, 4 elements. Okay, so if you use an array, what will happen? Let's say if you use a string array. Okay, string array, let's say names, and then I initialize it to 1, 2. Then, okay, or I'll just use new. Okay, okay. So let's say I initialize it to 1 and 2. Something like that. So can I actually add more items to it? No, right? Because the size is now fixed. And obviously you can actually fix the size. And from there, you will not be able to add any more elements, right? So that's the idea here. You notice that the index maximum will be up to, for example, if you use new string 10, then you can only have 10 elements, all right? So if you change this to new string something, then the array size is actually fixed. Okay, so typo here. So say that I have new string like this, and I say names 0, I have a value. Okay, names 1. Sorry, what happened to my keyboard? It's actually showing brightness instead. Okay. All right. And then if I try this names 2, what will happen? So with pass here, what do you think? Okay, when you try to run it, it says index outbound, right? Immediately So that means you cannot actually go beyond that. So that will be the downside of having an array as compared to an array list. So I'll go further. All right. So the size can change dynamically. I think we have mentioned about the danger of remove in a loop, right? So in a loop, when you try to remove, this is dangerous. Okay. And then next, using a linked list. Okay, a linked list is a very common way of storing arrays of data. And the major benefit of linked list is that you do not specify a fixed size for your list. So the size is variable. And then data structures such as stack, queue, binary trees, and so on, they are often implemented using linked lists. Okay. And we have also seen the disadvantage of array. You cannot add beyond the maximum size that you have allocated. Okay. But for linked lists, of course, you can add and remove at any position. Okay. So if you look at linked lists, the good thing is you can, for example, initially start with a empty link, then it will start linking to the next element, next element, next element. So you have 3. If you remove 2, then the first and the third will be connected together, right? And the only one that's removed is number 2. And again, for whatever reason, if you want to add back node 2 in between 1 and 3, then the reference for 1 will be set to 2 and 2 will be set to 3. So automatically, by using a linked list, the connection between them will be joined automatically. All right. So, and then if you compare an array and a linked list, of course, a linked list allows traversal both from begin to the end and from end to beginning. And that's why we say that they have a head and tail. All right. So if you use a linked list, then you notice that the definition for linked list is very straightforward. Okay. If you want to use a linked list, okay, all you have to do is just declare a linked list. Let's say name. Okay. And then this will be a new linked list. And we haven't actually defined the size yet. And when we want to use the linked list, how do I add the element? So the same way, in fact, you notice that the same way. And apart from adding object, of course, we can also add anything that we like. For example, add name, okay, something like that. And you notice that, well, this will tell you that, okay, it belongs to the raw type linked list. And anything about this one should be parameterized, right? So that's to say that, okay, if we have something defined like this one, then we need to parameterize the type over here. So let's say we say string, then it's done, okay? So remember that even though we didn't actually specify just now, it's just an orange color highlight, right? That's to say that, okay, there's something that needs to be checked, but there's nothing wrong. It will still run, okay? So take note that linked list is just like our normal array list. The way we use it, add and remove, will be the same. And you can even add to the first or add to the last, okay? So if you add to the first, then you notice that when you traverse the linked list, in this case, for let's say string as in name, then I'll do this. System.out.print line as, and then you will be able to actually show you after you've added my in front of name, what will happen? Okay, before that, let's remove this error first. If not, it will be here to stay, all right? So you see, my name was printed. It was before, right? So this thing was added to the first, that means before your name. And to add to the last, of course, it's just the same as adding to the next. Like, for example, if you say name.add is, then this is how it looks like. Okay, my name is. Because if you do not specify, it will always be added to the back. All right? So that is the idea of a linked list. So linked list, the structure, everything, when we use it, is about the same as your array list. And the good thing about linked list is that you can move forward and backward, and you can actually remove element, and the elements are all connected together. So this will be a useful data structure to implement queue, for example, because if somebody just withdraw and then you want to know who's the next person to call, then this is going to be useful if you are using a linked list. All right. So the usage will be similar. The real difference is their underlying implementation and their operation complexity, right? So when you use a linked list, of course, this is something like this. I think we don't have to mention it. It's all shown here. You can try out the code, in fact. So this will give you a list of fruits, right? So the list will be orange, apple, grape, banana, and so on. And then the size of linked list, everything will be shown. And next, okay, how do we choose between array, array list, and linked list? So if you need to support random access through an index without inserting or removing elements, then obviously array list will be the most efficient, okay? So you want a list, right? And random access through the index, then this will be best use array list. If let's say your application requires insertion and deletion, definitely it's linked list, right? Because you have multiple insertion and removal, then linked list will be the way to go. And if let's say you have a fixed array or fixed value, then it's best that you go for array. For example, if I have a fixed number of seats, for example, let's say I want to design a program for theater seats. Theater seats are fixed, right? So I will just have to initialize an array of fixed number, let's say 1 to 30 for every row, then that's fine, right? You don't actually have to use complicated structures like linked list or array list, right? If it's completely fixed, permanent, then use just array, okay? So that's the decision when you want to actually decide what to use, all right? So make sure you understand this. And then the next thing, of course, in brief, linked list should be preferred if there are no large number of random access elements. Okay, so if there are very large random access element, then we go for array list. Okay, and there's no, if let's say there's a large add and removal, then the most efficient data structure is still linked list, right? So array list is going to be useful only for random access, right? Large random access. And they are not efficient if you want to perform a lot of add and remove, all right? Okay. So one interesting feature in Java collection framework, sometimes we shorten it to JCF, is that there's a list iterator that you can use to move forward and backward. And that list iterator can work with all the Java collections framework. Let's see how it's done. Okay, so for example, if let's say you want to start looking at elements, right, the cursor position will start from the very beginning, right? If you want to look at the first element, of course, you will be placing your cursor here. And after you examine your first element, it will go to the next in between, right? And then you look at the next, the next, the next. So how would we use that to actually replace the loop? Of course, we can use an iterator. We are going to talk about iterator class later. An iterator, in fact, is supposed to be an interface, right? So you notice that iterator, the most primitive one is an interface. The list iterator also is a type of interface. And that type of interface allows you to have flexibility to do a few things. You can actually add element. You can actually check for previous element, go for next index, previous element, or you go for the next element also. You can do that, right? So let's see how to actually add a list iterator. To use a list iterator, of course, you first must create a list. Okay, so over here, you create a list of type integer, and we set it to be a new array list. Okay, so this is possible because you know that list is the interface that is being inherited by array list. So that means this is supposed to be the super class, right? The super interface, and this will be the implementer. So therefore, this is allowed. Okay, so in that sense, your list now becomes array list after you have implemented this part, right? And then your list iterator must also have a type being associated with it. If you don't associate a type, definitely it will not run. And you are going to set your list iterator to null initially. And then we are going to basically connect our list iterator, in this case, with the following command, right? So your list.list iterator will return back a list iterator to your this one, right? But this is actually quite long, right? So the easiest way, of course, we have already got the list here, right? So let's use the list as an example. Okay, so how do we actually connect them together? So firstly, you might want to actually declare a list iterator. Okay, li is assigned in this case, you have a list already, like for example, name list dot list iterator. And there you go. Now you have a list iterator that you can actually use. And don't forget the type, okay? The type must be specified. If not, then it will tell you that the type wasn't specified, right? So remember that the list iterator also have this particular notation, right? That you have to actually specify the type that is contained in the list iterator here, right? And then you can actually use methods to actually access the list now. So one of the methods that we can actually use will be now that the list iterator is already set up, okay? So you can use the list iterator to check for whether there's a next element or not, okay? System.out.println, we can actually print from the list iterator, okay? Then I will be able to say, okay, li dot has next. So initially, of course, there's none, right? So here, initially, when you run it, obviously it says none because there's nothing, okay? Right, false, no element, right? And if let's say you go and implement the list iterator, okay, or let's say perform the operation after you have added some element. So what will be the output now is true, right? So after you've moved this one, that means there's a next element, in fact. Okay, so from the beginning, there's a next element. And how many next elements are there? Okay, it will be up to maximum of 4 here, right? So I hope you get the idea. And in fact, for the list iterator, we can actually use this particular feature. Okay, let's say, how do we know whether there's okay, there's a next index or whatever? You can use next index to get the next index. Okay, so this can be useful in for loop, right? So in a for loop, of course, you can use this particular feature. I think it will be shown shortly. So this will allow you to actually see whether you have the next element or the previous element. All right. So that is, of course, some of the good thing about your list iterator. So can we actually use our list iterator in a for loop? Well, obviously you can, right? Okay. And the step will be the same like in your conventional for loop. Okay. So normally, how do we actually declare them? So let's remove this one. You don't need this line. Okay. And we can actually move this one as the first part of your for loop, right? For list iterator li is assigned the name list.list iterator, and then we have has next, then li dot. So what should we do? You might be able to actually go for the next one, right? Right. So how do we actually move the list? Okay, so you can actually use li.next anyway, right? And then right. So let's do this. We can actually use the word set or get to basically get the values, right? So over here, you can actually use the next index to use the next index that you want, okay? And then we use the has next to actually move the list in this case, right? So let's do this. String system.out.println, and then I'm going to print the list dot next, and it will basically be able to show the list. Okay, so let's move it. And the rest of this, just to shorten it, right? So we might not want to show this one anymore. So when you use a list iterator, of course, you are able to loop through the list and so on. And then this name and so on, we don't want it anymore. So let's run it. Okay, so take note that if you use this format, the last one, there's no need to actually advance using an I++ or whatever, right? So this one, you use list.next to go for the next element. And then what it prints Steve Teo was here, right? So size 4, and then this one will print the list as usual. All right? So hope you get the idea. In fact, if you use a list iterator, it will allow you to actually traverse the list like the following. Okay, and of course, this part is not actually mentioned in your lecture notes or whatever, right? So I just want you to know that there's this way, but this is not a very elegant way because you notice that you need to actually declare list iterator once, okay? And then list iterator has next to check for the condition. For as long as there's next, then we will start printing. And if you use list.next, of course, it's going to print the next element, right? So we are going to start from the beginning, right? Beginning is, of course, just like the linked list that we have just now, right? Okay, so then we can actually do things like that, okay? And some people will be asking, can I actually do this to my linked list? Will it be applicable to name? That's your linked list. Is it possible? Right. So if you're going to use name for your linked list and so on, right? So will this be applicable? What do you think? Right. So let's change it and see whether the same method can be used or not. Okay. So we are going to print name.size instead. Same thing, right? We notice that if you change from array list to linked list, the same output will apply, and the same iterator can be used for that particular linked list, right? Whether it's array list or linked list, things will work the same way, right? So all you have to do is just first initialize your list iterator to point to your list.list iterator, okay? And then once you have the list.list iterator, you can actually iterate through the elements. As long as there's an element, then it will go and repeat the loop, right? List.has next, true, then it will move, okay? Then you use list.next to advance to the next element, right? In fact, you start from now, right? From blank, then you print the first element, Steve, then followed by Theo, was here, and then the fifth one, of course, the end of your linked list, okay? It points to nothing, right? Then it will return a false after that, okay? So then has next will return a false after Steve Theo was here. All right, okay. So hopefully you get the idea about how to use this. It's not actually mentioned in the slides, so I hope you can actually learn from it. Okay, before we proceed, of course, I would like you to also, okay, this will be next. I'm going to share this code also in the chat. Right, so for those who have not signed in, please use this code, MDD2JS. Right? Okay. So an exercise was given here. Write a program that lets user enter numbers from console and display them in let's say J option pane message box. Use a linked list to store the numbers. Do not store duplicate numbers. So when we use a linked list, definitely it is very useful. It will allow you to store in the right position, right? And how do we check for duplicates? You just use the .contains, right? .contains. So this one, I'll leave it for you to try out. Okay. So when we use J option pane, of course, this is using Java Swing, right? So anyway, this is just an exercise. I'll let you try it out first. Okay. And then the last JCF that we want to talk about, this is by far the most useful because it can be used to create a lookup table. And you can actually create a key value pair that someone can look up for some values and then immediately do something. Like for example, if let's say you're storing values that you can look up for example, some of the most convenient use will be, of course, your, for example, okay, so what's the best lookup that you want to create? Like for example, your multiplication table, right? So multiplication table, sometimes you don't want to memorize the value. You just want to make a table out of those values, right? So then you can actually create what we call as a lookup table, right? Okay, so how does it look like? Don't worry, this is just a simple screen to illustrate to you the hierarchy. Okay, we have already seen set and list, okay? So set allows unique value, right? Remember that. And how to actually convert to a set, I will show it to you shortly. But if we do not have time, then I'll show it to you in a separate video, right? Okay, so firstly, a set, of course, allows unique values to be entered to your data structure. And a list, in this case, can be ordered or not ordered, right? It depends on the type, okay? The queue, in fact, this is actually coming from your linked list, right? So queue and linked list, they are very symmetry, right? Very similar. And if you look at it, linked list is actually coming from queue over here, right? Whereas list, we can actually derive an array list from here. So the structure looks very similar because all of them are actually deriving from collection. So that's why the method used will be similar, right? So that's the beauty of using interface in Java, because when you create using an interface, your method name seems to be quite standard, right? Okay. And on top of that, of course, we can also have other things like link hash set and so on. So these are set anyway. Okay. And let's have a look at, sorry, it moves a bit too far. Right. The one that I want to talk about is map. Map is the last data structure that we want to talk about because this is by far the most useful, right? And how do we declare a map? Firstly, you know that map is actually being inherited, right? These are interfaces. You notice that we start from interfaces, and then when you inherit, then there's a so-called abstract class that was created called abstract map, because this is an incomplete class. In fact, we know that this is an incomplete class that implements partially the map function. And then the one that's completely created will be the concrete classes called hash map and tree map. So these are the two map methods or map classes that we can actually use. And if you use abstract map and so on, they are incomplete. There are many methods that you have to create on your own. So best is you use these two only, right? And of course, the ultimate one is link hash map that can actually do a lot more wonderful things, right? So let's have a look at it. Map and tree map, okay? Hash map, tree map. Okay. So say that if you were to implement a no-fly list, right? It is a list. And then you need to actually maintain the no-fly list with some data. And what is the most efficient data to use? Let's have a look at the format. The format consists of two things, okay? First, if we use a set, and then these are the so-called location that you want to fly to, right? And then if you create a set using a hash set in this case, and then you add the elements, then you will be able to actually print out the set's value by using the same for loop structure, right? And then if you add one more, of course, this shouldn't have allowed, because by right, if you try to do something like this, what happened? Okay. Well, you have Paris that is actually duplicated, right? But it will still be able to print the hash set carefully. And obviously, using a set will allow us to actually overcome a lot of those issues of duplicates, all right? Okay. And then this is a map. Not this map, actually. We are not referring to this map. Okay. So let's have a look at a no-fly list, right? So by right, a map is the most efficient data structure for us to use. And we can actually use an index for a list of elements, as we shall show later. And what's a map? A map is basically an object that maps a key to a value, something like this. So say that for your map, the map interface actually maps your search key to a corresponding value. So in that case, your search key can be a unique value, right? And that value can be integer, float, or even string. So like, for example, your search number over here is 111-34-3434, right? So this search key is actually alphanumeric, okay? And it comes with a dash. If you don't want the dash, of course, you can omit it and make the whole search key to be integer, all right? And then in list, the indexes are integer. In map, they can be any, right? So using a map, of course, will be more useful. Let me just illustrate using a code over here. So we have actually learned about linked lists and so on. How about creating a map then? So to create a map, of course, we need to actually create a type of map. In this case, map followed by two values. Don't forget that for a map, you need two values. Right? The first one will be your key. The key can be, let's say, a string. the value can be, for example, the value that you want to store can be, let's say, a value that you want to store. Let's say your result float. Okay, and then I call this as exam, for example, and then this will be a new hash map, for example. Okay, new hash map. There's a typo here. Sorry about that. And don't forget that hash map needs to be imported. All right, and map also. Once you imported it, then there should be no error. All right. But of course, some people will be asking, why don't we just use the keyword directly, hash map here? Well, you can. There's no harm, right? I'm just showing you that you can actually assign the parent class variable to a subtype. So this is subtype polymorphism. We know that this is possible. All right. Okay. And then once you have declared a map, we can actually add the mapping value. How do we add the value then? So we can just use exam dot. Okay. The keyword is different. Remember that previously when we use set and when we use a list, right? So the keyword that we use to add element is called add, right? But here we are using the keyword put instead. And then when you put the value, of course, it has to be a pair. Right? In this case, Steve, okay, Steve's score is only 10 marks, right? Very bad. And then, okay. So remember the put itself, you must put in the right value, right? And then if the value that you put is not applicable to the double value that we have here, then you have to actually cast it to float. So it's best sometimes be careful of the data type, right? It's quite sensitive because it thought that 10.0 is actually a double value, right? So then we make it into a double anyway. So this will allow the error to be eliminated, right? Sometimes you don't understand, like why is it not accepting float? Well, it's because when we assign the value, it thought that 10.0 is a double, right? So then we can actually add your exam value, right? Exam results, okay? All right, like this. Okay, so then, again, integer, not allowed, right? Right, so that's why it's sometimes very sensitive. And in order to actually get the right type, you got to be careful, right? So whenever you put that, make sure that the data that you put is of right data type. And then how do we actually read the text from the list, okay? So don't worry, actually you can use the following, right? And then one thing about the advanced for, when you want to use it in conjunction with your, in this case, your hash map, is that you must always declare the element, in this case, right, of what type? Okay, so this will be a bit challenging because your element should be of this type, right? So how do we actually work around that? Let me just show it to you. Okay, there's a key value pair that you need to map, right? And then don't worry about all this mapping. The element is always being mapped using K and V. So all these are explanations about the mapping. When you put an element, of course, it goes line by line in that case. And then when you put a key value pair, so you are able to actually add elements or remove element by using clear, right? Or remove. So the keyword remove is the same, right? And then let me just show one code to you how to actually add this element. And your string key that you want, in this case, okay, that's depending on what you want to use. If I want to actually refer to the string key here, so then I'll just say string key. And this will be coming from my list. What is the list name? Exam, right? Exam dot, okay, entry set. Entry set actually returns a key pair of string and double, which we don't want, right? So if you want to just return the key, so what do we use? We use key set instead, right? So be careful because the key set returns a set of Steve, Ali, and so on, right? Then you can actually, in fact, you could have actually done something like this: system.out.println, and then I can print exam.keyset. Okay, so if I use the method exam.keyset, what do I get? I'm going to actually print the entire list. So it's actually going to be in a list format, right? So in a list format for that. And then if you want to actually print the key, then you will just have to do system.out.println key. Okay, so that will be the method that you can use. So let's hide this part and focus on just the. Right. So you notice that if you print, in this case, the key set, it is in a set notation, right? In a set notation. Square brackets, Steve, Ali will be the value. And if you print individual values, then this is what you get. So suppose that you want to actually retrieve the entire key set. So how do we actually read that? In fact, you can just say for in this case, key set. And from which particular list that we want to extract the key set. So this is, of course, exam, right? And then you need to actually specify carefully what is in the key set. All right. So the key set, of course, will have, in this case, string and double. All right. And don't forget to actually have this. All right. And you need to actually return the key set from here. From exam, we need to actually return the key set. Okay. And for each key in your key set, you can convert to string and what's that? Sorry about that. Element of type string. Oh, sorry, I think this is wrong. This is supposed to be entry set. I used the wrong word. Entry set. Okay. And E is supposed to be small letter. Okay, I think I mixed up some of the things. All right. Did I mix up any of those? They're supposed to return a set, in this case, of entry. They are not being able to convert to entry set, string double, element type. Okay. Okay, I'll come back to this one later, don't worry. As long as you know how to use the key set over here. And also we can actually scroll through, instead of key set, I can also scroll through the results set in this case, okay? So that means the value pair. The value can actually be used, right? So instead of looking at that, I can actually look at the key set actually returns the set of string, as you can see here, right? And then there's also another set that I can use. There's your value. Okay, sorry. It's called values, right? So then I can actually use the value and print out. Okay, so this one, just a moment. Let me just fix the things here. All right. So set will return set, and then values will return a list of values. All right. And when you try to print out the same thing, then it will be able to allow you to see the values in a set format. Okay, so you can just use example values to print the list like this. Okay, so this will be a list of values. All right. Okay. So hopefully I've explained about this part to you. In fact, this is a very long chapter, right? And many of those things are not really directly related. You notice that somehow it jumps from hash map to something else and so on, which I don't quite like. Okay, the add and remove, of course, is called put or remove, right? And then on top of that, you can use the get to actually get a key, right? So like, for example, if you use student grades.get key, then I will be able to get the student grade, right? And you need to supply this key. The key is actually the name, right? You notice that that's the one that we need to actually use. And if by using key set, we'll be able to actually scroll through the keys and make use of that for the values. So if you want to actually make use of the entire item, obviously, it will look somehow different, right? So I'll figure out this one, and then I'll let you know how to actually make use of the entire structure, right? In terms of the entry set. Okay, the entry set is of course like what we have just now, right? Okay, but anyway, using key set or using values will allow you to actually retrieve the value. So, and then if you want to print the value of some keys, so what you could have done is you can actually do this. Like for example, system.out.println, and then I'm going to use the exam.get, and then I need to just get the index, right? So the key in this case will be the key that I use, all right? Something like that, and then I'll be able to actually print the content. Okay. Right. So once you have that, when you run your loop, of course, it's going to print the value, right, like this. Okay, so that will be actually what's highlighted here, and we still have some more information to go through. So the last part on the tree map, of course, I can actually let you read on your own. The map itself, there's tree map, sorted map, and also hash map that we can actually use. So all of them come with different features. You might want to actually have a look at it, okay? And then the most important thing, of course, hash map and tree map. Hash map is faster. Tree map guarantees the order of iteration. That is, it sorts the order, all right? And then the rest of the application, of course, this is a long list, right? So I don't want to bother you too much with the list, but when to choose what to use, this is important, okay? So for Java util.collection, you notice that for set, they are normally being used when duplicate entries are not allowed, okay? So if you want unique value, go for set. If you want a mapping of key value pair, then we go for map, right? So if there's a key value pair, use map. If there are no duplicates allowed, then we go for set. If other than that, right, no mapping to key, no duplicate, that means no requirement for checking duplicates, right? So no uniqueness is required, then we can actually go for a list. A list is more versatile in that case. You can actually check and see whether you want to use a linked list or array list. So if it's mostly accessed at the beginning of n, then most likely it's a linked list, right? And if the list is of significant size, then we would probably look for linked list also. And if, let's say, the entries are often added or removed, then it's still a linked list. Okay, so other than that, we can use ArrayList for our normal purpose, for not so frequently updated list. Okay, so the last word, of course, using a Java API, you need to learn how to use them. All right, so that's probably what we can talk about. I will do a proper recording. In fact, I don't like this session because it is kind of messed up, right? Okay, right? So it's kind of messed up. And okay, we'll stop here. So I will stop the recording, and then it's better